Today we are going to discuss solid principles. These are 5 principles and we are going to look into them one by one. So solid principles play a crucial role when it comes to writing flexible, scalable, maintainable and reusable code. The solid principles were introduced by Robert C. Martin, also known as Uncle Bob. So we should remember the name that who introduced solid principles, Robert C. Martin. Now let us come back to the solid principles. These are 5 principles. First one is single responsibility principle. Second one is open close. Third one is Leskov substitution principle or LSP. Fourth is interface segregation. Fifth is dependency inversion. So what are the benefits of solid principle? Solid is a structured design approach that ensures that we are building software in a modular way, which is easy to maintain, understand, debug and refactor. So let's look into these 5 principles into a little bit more depth. The first one is single responsibility principle. It says that every class in Java should have a single responsibility or a single job to do. To be more precise, that there should be only one reason for the Java class to change. Let us look into the example. We have a public class, vehicle class, and in there we have 3 different methods. The methods are print details, calculate value and add vehicle to database. Here we can see that the vehicle class has 3 separate responsibilities: reporting, calculation and database. Adding it to database by applying single responsibility principle, we can see that the above class has multiple responsibilities given to it, so it is not obeying single responsibility principle. What we can do here is we can instead of putting these 3 different functionalities in the same class, we can have 3 separate classes to work out with. The second one is open close principle. Now what open close principle says is that a class should be open for extension but it should be closed for modification. We can take the example of there we have created a vehicle calculations class, and here this everything is working fine, but if you want to add another subclass called truck, then what happens is it works, but when it is not following against the principle of open close. A better approach would be that we make a vehicle class and then we make 2 classes, that is a car class and a truck class, and extend that vehicle class and provide implementation of the calculate value method that we have done. So this calculate value method can be overridden, and these car and truck class can extend the vehicle class and provide their own implementations for that class, for that particular method. The third one is Leskov substitution principle. The Leskov substitution principle applies when we have parent class and child class, and it says that the derived classes must be completely substitutable for their base class. In other words, we can say that if a class A is a subtype of class B, we should be able to replace B with A without disrupting the behavior of our program or the behavior or functionality of our current class. The example we can take is that we have 2 classes, square and rectangle class. Square is a derived class, so in rectangle we have height and width, and we are setting the height and width by 2 methods, set height and set width. Now class square extends this rectangle class, so it is also providing it is also implementing these methods, set height and set width. Now we can see that this doesn't obey Leskov substitution principle, because you cannot replace the rectangle base class with the derived class square class, because square has an extra constraint, that is the height and width must be same. So it is not obeying Leskov substitution principles. What we can do here is we can have a shape class, and then in shape class what we can do is these square and rectangle class can extend the shape class, and we can have some methods in that shape class which this square and rectangle class can override those methods. The fourth one is interface segregation principle. The interface segregation principle states that clients should not be forced to depend upon interface members that they do not use. In simple words, we want to say that we are not forcing any of the classes to implement an interface that is irrelevant to them. We can take the example of a vehicle class and a bike class. Here vehicle is an interface, and in interface we have methods like drive, stop, refuel, open doors. Now if we are making a bike class that implements the vehicle interface, we have to implement the method open doors, but we can see that it doesn't make any sense for bike class to implement the open doors method, as bike is a two-wheeler and open doors method is for a four-wheeler, that is a car. So what we can see here is that interface has to be broken down into smaller multiple cohesive interfaces so that no class is forced to implement any interface. The fifth one is, and the final one is, dependency inversion principle, which states that we should depend on abstractions. And what are the abstraction? Interfaces and abstract classes instead of concrete class implementations, and the abstraction should not depend on details, instead the details should depend on abstractions. So what we have taken an example of a car class that depends upon a concrete class, that is the engine class. Now this engine class is a concrete class and there is a car class, and in engine class there is a start method. Now what we can see here is that this code is working fine, but what will happen if we have different kinds of engine like petrol engine or diesel engine? Then it won't be able to work that efficiently. So what we can do here is we can solve this problem by introducing a layer of abstraction. The layer of abstraction will be that we can define, instead of engine class, we can define engine as an interface, and then that interface will be implemented by classes. Like we can have a class petrol engine, and this class will implement the engine interface and provides its own functionality of a start method. We can have a class diesel engine that implements this engine interface and provides its own implementations of start method. So these are the 5 basic principles, solid design principles that we have discussed. Just remember the 5 principles. First is single responsibility, second is open close, third one is Liskov substitution principle, fourth is interface segregation, fifth one is dependency inversion principle. So just remember the names as well as in details how they work. Thanks a lot for your time. Thanks for your